Hello everyone, welcome back to lecture 21, ECE350. Today we're going to talk about elliptical polarization and we'll give you some application of polarization over here. And let's see, what is elliptical polarization? It looks very complicated, right? So let me go through this over here. So there are two axes for elliptical polarization. One is called major axis, jet axis. One is a minor axis called eta axis. You can see that here, this axis over here, right from here to here, this is your major axis, zeta, and this is minor axis eta, right? So with these two axes, there are two other angle you have to be careful here is that electricity angle over here, C, all right, and also rotational angle, gamma, all right? So with this, all those angles over here, your two equations can describe this over here. One is tangent 2 gamma equal to tangent 2 C0 cosine delta. You know the delta over here, right? This is your the phase difference between x component and y component, and the sine 2c equal to sine 2 c0 sine gamma again. Okay, so now this is more important than anything else. This is more important than anything else. You see over here, your C angle, which is the electricity angle, can go between from negative 45 to positive 45. If it's 45, this angle is 45 over here, right? That means this cannot be that far, right? This 45 means x component, major axis, minor axis component should be equal to each other. That means you're going to form if it's 45, right? This angle is 45, that means you're forming your major axis, minor axis component should be equal to each other. That means AN and A zeta should be equal to each other. That means you're forming a circle. So 45, negative or positive 45 will form a circle. So that's why to a circle, your C is 45. For a line, your C needs to be 0, right? Because your for a line, it needs to come on one line here, right? So that means if your C equals 0, that means you're getting a linear polarization. So linear polarization and circular polarization is actually a subset of elliptical polarization. So it's all done by this angle over here, angle of electricity. If that is negative 45 or positive 45, you get circular polarization. If it's 0, you get linear polarization. In between any angle between 0 to positive 45 or 0 to negative 45, it will give you elliptical polarization. That's the key over here. So to understand that more, we're going to do this problem in the class, so you'll understand more about that concept. All right, so let's go back, and also we're going to do some simulation at class, so understand more of it visually, and also this one over here. All right, so tech brief. LCD, everyday life we use LCD display, right? What is LCD? LCD is basically a practical use of polarization. So your incoming waves, I'm going to go back to here on this one. Incoming wave coming from here, right? So that coming here, and over here you have your LCD. LCD is a liquid crystal. If you provide the enough voltage between two slides over here, so that voltage will straighten out the molecules over here, so that would not polarize incoming light. So the incoming light will go through is unpolarized, all right? But if you don't supply voltage, that molecule inside the LCD, we're gonna twist your incoming light like this. So you're gonna twist it. If you are going in X direction, you're gonna twist it to Y. So you're gonna twist it. If you twist it, then the polarization happen, right? This is the polarization over here. So molecular spiral, okay? So molecular spiral, you can stop it by applying enough voltage between positive and negative. If you don't apply voltage, then you're gonna make the twist of an incoming light. That means that light over here is coming, let's say, in vertically, then over here it become horizontal, right? So that it's become horizontal over here. It's coming vertical over here, it's become horizontal over here. So then if you have that filter here again, that filter only can horizontal or can go, then this two twisted one will go through the filter, and that will make your spot clear over here on the LCD screen, right? So that's why two clear spot right here is basically happen because of twisted pair inside the LCD. All right, so that's one of the polarization application in our daily life, which is LCD. That's how we're going to get to the lecture 22 in next video.